Hello, good afternoon everyone. Welcome to the class ECE341, the probability and stochastic process. Today we will keep working on the point estimation. This is ECE341. Now it is the 12th week. This is for the Monday's class. We consider the point estimation. Point estimation. We have this one. So last time we introduced this method, right? We use this one to approximate some, we call this moment. Then we can solve a parameter from here. Then we get an estimation of the parameter, right? So the idea is like this. So a random variable x has symbols x1, x2, xn, and x with n, or maybe several, right? Unknown parameter theta. Okay, so this is a x with unknown parameter theta. Then we have find an estimation of theta. Theta bar, theta hat equal to something. Here's something. You use those xi's, do some calculation. X theta, use theta hat to be an estimator of theta. Theta hat is calculated based on those xi's. Okay. And then the moment method is here. Right? We have the moment method. Why is moment method? Actually, we have this e of x to the k. This one is a k's moment. We use this name. We call this the k's moment. So we use this is a average, right? Kind of average. So we call this a mean value of x to the k's with n symbols. And this is a value you can calculate based on the symbols. When you have the symbols, you can calculate. Then you have a number. You want this number equal to this moment. Then you can solve the theta. Alright, so this is the moment method. And we have studied this example with different values, right? And this will be your homework. Okay, you will work on this day. And then last time I have worked on a different set of data, right, to the same problem. Okay, then during our work on this problem, we have sometimes we just estimate. We only need a e of x. We only need a e of x, then we can estimate the parameter. And some other problem, we need both ex and the variance of x. We need these two during our calculation. Then how to estimate the variance of x? Actually, here we have three ways to estimate the variance of x. The first one, this is straightforward from the moment method, right? Because we have these. This is the formula. We know this. Now, this e of x squared, I will replace by the mean value of x squared from n symbols. And here ex also replaced by the mean value of x from n symbols, right? Okay, so I replace these two by these values from the symbols. Then we have an estimator of variance of x. So this is one method. Second method, similar with the first, with this A. I call this is A. Similar with A, this is B. I use this one. This is the definition of variance. You see, this is the definition of the variance. Then in this definition, E of x I replaced by Mn of x. So the mean value of x from n samples. And xi is observed date, right? You have the date. So you put the date minus this mean. Mean also calculated from the sample date. Then you have add them together, do square, add them together, and divide by n. Then you have the variance, approximate of variance. So this is also an estimation. And it can be proved in A and B, you will have same result. So A and B give the same result. The formula looks different. The way to calculate is also different, but actually they are equal. They are totally equal. All right, A and B give the same result. And then we have the third way. It is this one. This is in case you already know what is E of x. Here E of x is not an estimation. It's a given value. It's a fixed value, true value, accurate value. Then in this case you do not need estimate because you already have it. So you just plug in, then you use the definition of the variance, right? And replace this Ex by the given value, and this x you will replace by the samples. So the formula looks like this. Part, right? The observed xi, the sample value of x, minus the mean value. Mean value is given. Then square, do summation. Then take average, divide by n. Then you have the estimate of the variance. Alright, so this is also a method. This formula only can be used when E of x is given. This is one side. Another side, if you already have E of x, then just use this formula. You do not need A and B, because in A and B you need to estimate what is x, what is the mean of x, right? Now you have it. You do not need to estimate. And here I stay here. In this case, I think I explained somewhere. When now here, I said here, if E is given, then this one is also an estimate. This is similar with B, similar with A. Just this is given E of x. However, this one is not good. Yeah, you replace the Ex. You just use Ex directly. The given value for Ex in C is fine, but if you use that in A, it's not good. So we don't use this. This one is not good. It looks, it's also an estimator, right? You can estimate. You can use this formula to estimate, but this result usually it is not good. In our example, actually the last homework, this one, in this case, here, the F, because the normal distribution with mu is 2, so Ex is given, right? In this case, when you estimate the value of sigma and the sigma square, you need to use C, but not this one, right? You use C, not this one. Alright. Okay, here actually we have a concept we need to make it clear. That means, what is a good estimation? What is a good estimation? For a good estimation, we have several things. Actually, 3 things we can consider. The first one, I will say, because this theta hat, I use theta hat. Theta hat is estimation of theta. This theta hat it's coming from the sample data. And every time when you take sample, you will have some random value, right? That means different time you will have different value. It's very hard to get the same value if you take sample next time, right? Like 1 day later you get same sample. No, the sample will have something different. So this theta hat, it is random value. Theta hat is random value. As a random value, random variable, let's call variable. Theta hat has mean value, right? Has expectation value. E of theta hat. We have this value. If E of theta hat equal to theta, then it is good. Theta hat is good. We call theta hat as unbiased estimation. Yeah, it's unbiased. That means, yeah, you still have some error, but the average will be good. Right? If you do this, you estimate like 10 times, you take average, that should be very close to theta. Right? The average will be that. And second one, theta is called asymptotes. Asymptotic unbiased estimation. If limit when that n, right? Theta hat is coming from these samples, n samples. Now the number of samples if increased to infinite, then theta hat, the mean of theta hat is theta. Alright, this condition is not as strong as the first. Right? In the first, the mean is just exactly equal to theta. This is unbiased estimation. Now you can have an estimation. The E of theta hat may not equal to theta. However, the limit is theta. So when you take more samples, you can have better estimation, right? Better estimate, right? Okay. So this is the second case, and the third one, we say theta hat is called. This is consistent estimation. If for any epsilon larger than 0, the limit when n go to infinite, the probability of theta hat minus theta larger than epsilon, this probability, the limit is 0. Okay, so what is meaning? This statement seems long. Okay, so this is we look at this limit. The inside is a probability, theta hat minus theta. That is the difference between these values, right? Theta is a number you want to estimate, and you use theta hat to estimate it. Of course, you have error. The error larger than epsilon. This is the event. The probability of this event will tend to be 0 when n tend to infinite. So that means for large n, you will have very small chance, so that theta hat has an error larger than theta. This is the error, right? This is the error bound. This is the error. Your error over epsilon, the probability of this will tend to be 0. Right? It's good, right? If this is 0, that's good. If this is small, it's also good. If this is large, then you will have a lot of chance you get theta hat is for different ways they say, right? So we want larger than epsilon. The probability of larger than epsilon is small. And also this epsilon could be any positive number. That means you can choose like epsilon is like 1/10 or 1%, or 0.00 with 10 to like 10 to -5 or 15 times, or like that, right? So you can set your you can think this is arrow bound. Then the arrow go over the arrow bound. That will be a event. That will be an event with 0 probability or a very tiny probability. Right? Limit is 0 itself, maybe a tiny number with a tiny probability. So that means in most cases, your set hat will very close to set with arrow smaller than epsilon. Right? Larger than epsilon, you have limit tend to be 0. Right? Okay, so this is the third case. So when we discuss estimation, we can use these 3 things to measure that estimation. Whether it is unbiased, whether it's consistent. If it is not unbiased, then whether it is asymptotic unbiased. All right. And then we can have a look for the example. We use that one, min of n x squared minus min of x squared to estimate to be an estimation of variance of x, whether it is unbiased. We want to know this, whether it is unbiased. Oh, sorry, it covered some. All right, so I will consider this. So I will say this is estimator of this one, right? Estimation of this one, whether it is good, whether it is unbiased. Now we just check. E of mn x squared minus mn x squared. Oh, here's capital N. This one, whether this equal to the variance of x. We need to do a calculation. Okay, this is the expectation value. Then I have 2 terms I can separate. So this one actually equal to E of this one. This one is mn of x squared minus E of mn x squared. All right, we have these. We want to check whether these 2 are same. All right, we'll do the calculation. E of mn x squared. What is mn? Mn is average, right? Average of these with n symbols. So we have symbol 1 squared plus symbol 2 squared plus symbol n squared. Take average and E of these, right? E of these. Then this one will be 1 over n. I can just move out of the expectation value, and E of summation of them. So it is just the E of x1 squared plus E x2 squared plus E of xn squared. Right, we have these. And each xi, it has same distribution, right? With x, right? It is a symbol of x. Right? It's still x. So same distribution. Then we will say E of xi squared It is just e of x squared, right? The same thing. The same thing. Oh, let me close that one. All right. Okay. Yeah. I want to calculate this. Now each one is just the same one. So the e of mn of x squared, this one, it is this summation, but each term are same. How many terms do we have? N terms. N cancel. So after divide by n, we have just one of these. So this is just e of x squared. Okay. So this part is just the same as this one. And secondly, we have two terms, right? We have this one and this one. What is this one? E of mn of x squared. And plug in. What is mnx? It is the average of x. So just do summation and divide by n, right? This is a mean of x with n samples. It is just this one. And I take a square. And by square, the n I have square, I move it out, n squared. The expectation of this one times itself. So it will be summation of all the xi, xj, and I run from 1 to n, j is also run from 1 to n, right? This one. Okay, now let me separate. Now the summation, right, for different I, different j. I separate them as two cases, I equal to j or I do not equal to j. 1 over n squared. I say e of summation for e of xi squared. Right? I run 1 from 1 to n. This is all the case. I equal to j. Right? And the rest term I do not equal to j. Right? They are e of xi times xj. We have this. We have this. How to say? Yeah, let me just going up. N squared. Okay, the summation, the first term. This term, e of x squared, similarly, it is just this one, right? Same with this part. Same with this part. Right? E of x squared, xi squared. So each one is just ex squared. So this is totally I have n terms, n of e of x squared. Is this one. And they are different. They are different. We know xi, xj are independent. We always with this assumption. That means for different I, different j, you take sample of x, right? At different time, they are independent. They are independent. So we have an independent sample chip. Okay. So they are independent. They are independent. So they will be just it is exi times exj. Right? For I do not equal to j. Right? This one. And then this one is what? This is e of x, right? Because xi is the sample of x. And this one is also e of x. This is another sample. So both are e of x times x. So I have, okay, I put this together, n and then cancel. This is 1 over n times ex squared. Right? And this part, I have how many terms? How many terms? Every term both are ex, so they are ex squared, right? Every term is this one, ex squared. And totally how many terms? I do not equal to j. I do not equal to j. And I and the j will be value between 1 and n. So this one totally we have n square symbols, n square different choice, right? N square, and I not equal to j like this. This side is I, this side is j. Totally I have n square choice, right? N square point, and we do not need they are same, right? This is I, this is j. When they are same, this point, right? This point related with those, they are same. They are same. I need to remove that. So totally is n square minus here we have n. Alright, so we have this. We have this. Then what is this one? I need to combine together. Can I do some simpler? Oh, like this. N. Yeah, here's n. Here's n squared. Like this, alright. Now I can cancel 1 of n. This is 1 over n times e of x squared plus n minus 1 times ex squared. Right, I have these. So we have the overall thing. We have two terms, right here. Now we have two terms. Then this term I get the result. This term I also get the result. Now I plug in. So we have the first one, e of mnx squared is this one, just ex squared, right? Ex squared. So this is a e of x squared. The minus e of nx squared. E of nx squared equal to this one, right? It is this one. So I need a minus 1 over n times e of x squared plus n minus 1 e of x squared. Okay, so we have this, right? So this one is this one, and this one is obtained at here, right? At here. All right. We want to check whether this one equal to variance of x, right? We check this one. Then we do simplify these two. They are same term, right? E of x squared. I put it together with coefficient 1 minus 1n times e of x squared. And then this term I use, and I have this one. This one is minus n minus 1 over n, right? N minus 1 over n times ex squared. I want to see whether they are same. Yeah, I think this is different, right? You have an n here. Alright, what it is? This is just 1 minus 1 over n, right? So both has this constant, so I have 1 minus 1 over n times e of x squared, is this, and minus ex squared, is this. Whether this equal to variance of x, I would say no, because we know this part is variance of x, right? So this part, it is 1 minus 1 over n in the front, so this is a smaller. Here's not same. This side is smaller, right? You times this one. This number is smaller than 1, so you have a smaller estimation. You use these. You use these as an estimation of variance of x. You cannot have the mean of this equal to this. The mean of this actually it is smaller than this. Now we'll say mnx squared minus mnx squared is not an unbiased estimation of variance of x. So we know it's not not an unbiased one. Somehow we can say this is not so good, but it is asymptotic estimation. Why? Because that 1 over n, the limit when n go to infinite, this one, it is 1. Okay. You have a number here, because this one, so they are not same, right? They are not same. Then because this they are not same. So when n is large, this is close to 1, right? This is close to 1. So after n large enough, you think they are very close. The difference between them is just 1 over n. 1 over n. It's a small number, right? Okay. Then we can build biased we can build unbiased estimation. Now we know E of this one, mn x squared minus mn x squared equal to 1 minus 1 over n times variance of x. Right? We have this one. Right? E of this, it is this part. It is just this one. 1 minus 1 over n times this is variance of x. Right? We have this one. Now, so let s squared, this is just a notation, okay, I denote this as s squared equal to mn x squared minus mn of x squared over 1 minus 1 over n. Then E of s squared will equal to what? Right, it divided to this side, so the whole thing is s squared. So E of s squared, it is just the variance of x. Alright, now we can use s squared to estimate variance x. S squared is unbiased. It's unbiased. Alright, so we have s squared. S squared is unbiased. So we have a new estimator, new estimation. This estimation is unbiased. And okay, it is this one. But after you do some simplify, by some simplify, we have this one, s squared. It is this is a summation of xi minus the mean of x and the square over n minus 1. I see this one. So we can just use this one as an estimation of variance, and this one as a variance. And we use this one. You can see I have put it here. And we call it is a modified moment method. This one. Okay. It's unbiased modified. We are not using moment directly. If we use moment directly, we need to use this one as a variance, as an estimation of variance. Now, I do not use this. I use this one divided by 1 over n, 1 minus 1 over n. So this is a modified one, right? if we use this, this is directly from moment method, and now we divide it by this number, I get S squared. So this is a modified moment method, unbiased modified moment method. For E of x, I still use this one to estimate it, but for variance, I use S squared to estimate it. And S squared, by simplifying, we can know S squared is this one. It is this one. Alright. Okay. So here I state here, S squared is also an estimation of variance of x, and S squared has expectation value, and it can be proved. This one, they are same. So S squared is an unbiased estimation of the variance of x. Of course, for this one, you look at the formula. Xi observe the date, right? You observe this value, your sample value, and this mean of x from n samples. This is also number coming from n samples. So all these calculations based on the samples. If E of x is given, here as I state here in part E, this one. When E of x is given, then we still do not use S squared. We will go back to use C. C is the last part. We use C here. We use this one. In this formula, this EX is given. Suppose this is given. You know this one. Then you use this formula. This part is not given from the samples. This E of x is not given from samples. This one is from samples. This one is from samples. Okay, the M and X is coming from samples. E of x is given. Okay, then we have some more homeworks. Actually, you see here, repeat problem 1 by using the unbiased modified moment method. The whole process to work exactly very similar with the first problem. The only thing different is when you calculate, you need to use S squared at the when you calculate this part, you need to divide by 1 over n minus 1, right? Then you have S squared as the estimation of the variance. Then you do all the rest calculation. The only different things here. Okay. And now let's look at these things in MATLAB. We have some functions in MATLAB can be used for the moment method, for the calculation of moment actually. Okay. First one, let's look at this one. The command is variance. We have give x. X is just like a 1, 2, 3. Suppose I have 3 samples of a random variable x. These values are 1, 2, and 3. And then we can use this function, variance of x. It will give us a variance. You see, we have 1. So what is this one? What is this one? This one, it is just that S squared. Now we can, let me calculate here. Example. Xi equal to, I just write it like this, 1, 2, 3, right? I have observed the 3 days. Then M, all these 3 samples, right? X squared minus M3x squared. What it is? divide by 3. Do I need to divide? Oh no, I just like this. This is the estimation of variance of x by moment method, right? Moment method. And what is this one? We can calculate. This is the average of square values. So 1 square, 2 square, 3 square over 3. And this is just average of them itself. So 1 plus 2 plus 3 and the square. Right. This one is 1, 4, and the 9 is 14. Right? 1 and 9 get 10, and the 2, 4, 14. Minus 3 squared is 9, and the numerator is 1, 2, 3, 6. 6 squared, 36. Okay, so this is what? Right, this is 9, and 3 times 14 minus 36. This is 30. 3, 4 is 12. 1, 3 is 3 plus 1 is 4. Minus 36 over 9. This is 6, right? 6 over 9. 6 over 9. 2 over 3. 0.66 something. Right? We have this one. And what is the variance of x? Let me see. Oh, I get this one, right? I get this one. I get this one as an estimation of variance of x. And in MATLAB, variance of x is 1. You see, different. What is this? What is this? You can see. What is s squared? S squared is 1 over n minus 1 summation of xi minus mn of x squared. This is this one. Right? This is s. This is s squared. Right? This is s squared. Divided by n minus 1 here. So let's go back here. So now n is 3. So this is 1 over 2. Right? Because n is 3. I have 3 samples. And the summation, so I have 3 terms. The d will be 1, 2, 3. So it's 1 minus the mean is this one, right? This one is m3 of x will equal to 6 over 3 is 2. Yeah, 1, 2, 3. Average is 2, right? Makes sense. It's 2. So this is 1 minus 2 square plus 2 minus 2 square plus 3 minus 2 square. Right. Okay, what it is? Here's 1 square plus 0 square plus 1 square again. This is negative 1 square is same. Negative 1 and 1 square are same. So this is what? This is 1. You got it? So in MATLAB variance of x, it is just s squared. Yeah, I use this to check. Right? I use this example. You can see the variance of x. Use the MATLAB function. It is just this one. And it has another function named mean. Mean of x. This should be 2. Yeah, this is correct. Right? Mean is 2. Right? So mean is same. It is 2. Just a summation divided by the whole amount. You get 2. Yeah. And MATLAB mean of x, it is summation of x over n. Right? Yeah. Okay, so this is these two numbers. When you do calculate, you can try to use MATLAB function. Because this kind of problem, you need to start from some observed samples. If here I only have 3 samples, that will be fine. You can calculate by your hand. It's not difficult. If you have samples like 20 or 30 samples, or even several hundred samples, then of course you don't want calculate by your hand. You need to try to use MATLAB to do it. Then you should know which kind of function can be used and want to know the exact meaning of those functions. So here you should know these two. Alright, the variance of x and the mean of x. This one actually gave you s squared. It is this one. Right. And the mean is this one. It's okay. Alright, that's all for today. I have 5 more minutes. What kind of thing can I do? Well, it's fine. Yeah, it's 5 minutes is not enough to do good job for start. It's not enough to do big job, and a small job is I don't have. Okay, then that's all for today. All right, see you next time. See you next time. Bye bye.